Hello and welcome to today's problem 424 longest repeating character placement. So you're given a string s and an integer k, and you're given the ability to choose any character of the string and change it to any other uppercase English character with the ability to do this at most k times. Given this ability, we want to return the length of the longest substring containing the same letter you can get after performing the above operations. Okay, so we're given two examples here. The first example, AB, is given the output expected is going to be 4 because you're allowed to replace the two A's with two B's or vice versa to return the length of the longest substring, which is the entire string itself. For example 2, you have A, and you can replace the A in the middle with a B in order to get 4 B's and have that be the output. So that's why the output is 4. Okay. So, taking a look at this problem, so an initial idea for this would be to have a sliding window. So we have AB. We could have a left and a right pointer, and we can basically iterate forward, right? So we have the right pointer iterating forward, checking to see whether or not a certain condition is valid, whether or not the sliding window is valid. So in our case, our condition is that all elements within the sliding window are the same character, or and given the ability that we can change any character of the string to any other uppercase English character, we're allowed to change at most k elements in order to have it match that substring. So another way we could word it is that we're allowed, like, every single element in the substring has to be the same character except for k elements that can be allowed. So I'll go ahead and write that down. So every character is same, allowing for up to k difference. So that's the condition we have to look out for. So with AB, basically what we can do is we can keep iterating that right pointer forward until you encounter an area in which that isn't the condition isn't valid any longer. So in this case, since we have k equals 2 in the first example, we can keep moving on this pointer all the way to the end, and at the very end, we can pretty much return the result, or basically the maximum of what the sliding window could have been. So yeah, so basically we can do that with the right pointer. With the left pointer, we want to modify the left pointer, modify the left pointer so that it moves forward every single time the condition is invalid up until it is valid, and at that point we can keep moving it forward. So let's say we have AA, BBA. We can have these two pointers over here. So pointer, and then what we do is we move the right pointer forward. Let's assume k is equal to 1. With B, we're allowed to modify that, so we can just move that forward. And then we have 4. We move on to this again, and we don't have any k longer. So what we have to do is we have to keep incrementing it forward until it's valid, till we pass that, whereupon we'll begin moving on forward. Okay. So this is where it gets a little bit tricky, and this is where we have to derive from differentiate ourselves from the standard sliding window problem, because the issue is once you have once you can allow up to k different characters, it might get a little bit more complicated. So, okay. So the first thing we probably need to do is have some sort of way to keep track of the elements we've gone through so far. So maybe what we could do is have a hash map. So maybe a hash map like this, which keeps track of the frequency of certain elements. So in the case of A, we can, as we move along forward, we could have a key A with a value like 1, 2, 3, depending on how frequently it occurs. And same thing with B, where you have, let's say, like it occurs once, etc., etc. So with this hash map, we can go ahead and check the condition with it. So basically what we can do is check to see what the maximum value in that hash map is, because that's what we want. Because we can change basically up to k characters. Since we know we can do that, we can change, let's say like for example b in order to match a, and we know that we want to change b to match a because a is the most frequently occurring. So we'll go ahead and write that down. We want to determine maximum occurring so far, and then from there what we want to do is change k elements to match that. Or actually, we don't need to change the k elements at all. Since we know the condition is allowing up to k elements, you want to see if basically the position from the end window minus the start window. So let's say like in this case, we have like 5 minus 1. We want to see if that basically ends minus or right minus left is the same or is greater than k. If it's greater than k, that means that the condition is broken and that we have to begin moving the basically the left pointer forward until it works again. Because once it exceeds k amount, the what is it? Oh, sorry. Yeah, right. Yeah, the right minus the left. Yeah. Wait. Let me think. Okay, so once for the hash map. Oh, sorry. Once the most frequently occurring, right? So instead of this, most frequently occurring. So most frequently occurring subtracted by. Oh yeah. So basically, while r right minus left, basically for every single, we can count the amount of characters that that are in the sliding window so far. So let's say 1 2 3 4 5, and then what we can do is we can subtract that with the most frequently occurring amount. And the reason why we want that to happen is because let's say like we have this example here, right? We have 1 2 3 A's and then like 2 B's over here. So the most frequently occurring amount is 3. It's A, so it happens 3 times. So this will be 3. This number will be 3. And then the total length of like of the sliding window, which is basically 5 minus 0, so it'll be 5. 5 minus 3 is 2. Is that amount greater than k? If it is, then we can switch those characters to match basically A. And if not, then like it's unable to happen and the condition is broken. So yeah, so this is how we can use the hash map and the frequency of the most occurring element in order to figure out whether or not the condition breaks and whether or not we want to switch the left pointer until the condition works again. So we'll use that to basically determine whether the condition is broken, and when the condition is valid, what we want to do is keep track of maximum of like the top length of sliding window, and then what we can do is return that as a result. So yeah, okay, if this makes sense, I'll go ahead and begin coding it up now. The first thing we need is our left pointer, so we can set that, and then we can also set the result that we're going to return afterward. So we have res equals 0. The next thing that we're going to want to do is basically iterate through the string. So for the value in, actually let's do a for I in range length string. What we're going to want to do is keep track of how frequently each character occurs, and we want to add that to the hash map. So to make this correct, we can get rid of this example here. Put this in we'll comment this out for now. Basically, what we can do is add to the hash map. So hash map at a given character. So let's say like s. Basically, oh yeah, we can change this to make it more clear from the I index to the right pointer, because that's what it is. We have the left and the right pointer, whereas the right pointer traverses forward. So basically we can do this. We can have the hash map at that current value equals hash map dot get itself. So here 0 and increment 1. So yeah, basically this initializes it as 0 if there isn't any value. If it is, it gets that and just adds 1 to it. It'll generate the hash map like we were talking about earlier, which we can then use later on. So the next thing we need to do is go ahead and check the condition. So while the right minus the left is right minus left minus the most frequently occurring, so max of the hash map's values, what we can do, whether or not that amount, if that amount is greater than k, then that means the condition is invalid. So we have to increment the left pointer by 1 until the condition is valid. And then also another thing we need to do is basically remove the frequency of that element from the hash map as well. So we can do hash map s hash map of the string at, instead of the right pointer, at the left pointer, we want that to equal itself. So HMap SL minus 1. So we'll go ahead and do that as well. So basically this will keep move left pointer forward until the condition is valid again. And from here, what we can do is after this while loop has occurred, we effectively know the condition is valid again. And what we can do is set the result here to equal the maximum of itself and the sliding window. So R minus L. Actually, we need to add 1 to this as well, because it's the nature of how like indexing works. So we'll go ahead and do that as well for this. And then after that, what we can do is basically at the end, we can just return the result over here. If we go ahead and take a look one more time, we'll read this over again. We have the hash map left and right. We iterate, basically traverse through with the right pointer. We start off here, keep traversing forward up until the condition is broken. So until the amount of basically the most frequently occurring subtracted by the okay, so basically the amount of characters in the sliding window subtracted by the most frequently occurring, check whether or not that's greater than k. If it is, the condition is broken. You want to remove that from the hash map, the frequency hash map, and you'll also want to increment that left pointer forward until the condition is valid again, whereupon you'll set that as the maximum result. And then after that, you want to turn that maximum value in order to basically return the output, which is the length of the longest substring containing the same character you can get. Yeah. Okay. So this makes sense. If we go ahead and run this. Okay, great. It's accepted. And okay. Okay, so actually a slight optimization we could do because we're constantly having to check what the maximum of the hash map is. It's pretty time CPU intensive operation to do this. So maybe what we could do instead is we could set the max frequency outside as a global variable over here. And then what we can do is we can set the max frequency here as the maximum of itself and the current count of the right pointer of the element or the character that's currently occurring at that given moment. This is more efficient because it's a constant operation to basically check what the count is of the current element and have that set to the max. That's better than having to basically check what the maximum is at every single point while you're doing the going through the iteration of the while loop. So yeah, if we go ahead and run this again, this should work as well. Oh, sorry. Slight syntax error. It's supposed to be hash map. We'll go ahead and run this. And there we go. All submissions accepted. Okay. Thank you for watching.